So today we are going to be working on division. And so I want to start by giving you the definition of division. And the definition of division is when you distribute some amount of stuff equally among a bunch of groups and then count how much ends in one group. Okay, so that definition is going to be very important during our division problem today. So today we are looking at 27,692 divided by 23. So basically saying I have 27,692 apples and I want to give some to 23 of my friends. How much are each of my friends, are all of my friends each going to get, right? Okay, so that first starts out by, let's divide. So when we divide, we always start with the largest number. Of course, we know when we multiply, we would multiply and we always start with the ones place. Well, now we are reversing our problem because we're trying to see how many of these apples we can give equally. So we start in the largest place value, which in this case is the 20,000th place. And so we are just imagining that it is a 2 for now, and all the other zeros are going to be invisible, and I'll explain why later. But so we look and we say, can 23 go into 2? Well, 23 is more than 2, so no, we know it cannot go into into 2. Okay, so then we look over the next number because then we move on to the next digit, the thousandth digit. Once we realize, okay, we can't put it in 2 times, so I need to move on to the next digit to see if it can go into either of those digits, right? Well, so now we're looking at this number together because we couldn't look at 2 alone. It wouldn't divide, but could it go into 27? And we know, based on over here, 23 times 1 is 23, so it could go in 1 time. 23 times 2 is 46, so no, it would not be able to go in twice. So we know that 23 can go into 21 or 27 1 time. Well, from here we know 23 and 27 are not equal, so there must be some left over. So what we're going to do is we have 23 times 1, we are going to subtract 27 minus 23. And now I want you all to imagine what we're basically saying is 27,000 minus 23,000. So we will just pretend that there are zeros there. They are just not currently relevant, but we'll draw them and so you can get a better image of. I'm not just saying 27,692 minus 23, right? Because that would give us a significantly different number. I am doing 27,692 minus 23,000. So we just put those, so we'll just add the zeros there for now. So 7 minus 3 we have is 4. And 2 minus 2 is 0. So we know. Well, now, just as I did for the 2, when I realized nothing could go in the 2, I moved to the next place value to see if anything else would go. And we see that we still have 3 more place values, and right now we're in the hundreds place. So I am going to bring my 6 down. And I do that to see if my 23 friends, like how many apples they're going to get, because I'm assuming they're going to get more than 4 apples based on the number, right? So we can bring the 6 down. And like I said before, that is basically like we are saying we are in the thousands place, so it's basically saying 46 or 4,600. We'll put those invisible zeros. So how many times does 23 go into 46? Well, 23 goes into 46. It goes in once for sure because 23 times 1 is 23. 23 times 2 is 46. So we know that it goes into it 2 times. So we put up 2 up here, and like we said, 23 times 2 is 46, so then we're going to subtract the 46, and we get 6 minus 6 is 0. 4 minus 4 is 0. Okay, so now we're going to move on to the next place value. And you can see that how we're doing it relating back to the definition. Look, we distributed, right now we tried distributing 23 to the 2. We couldn't do that. So we distributed 23 to the 27. So we know that in that case, we distributed 23 to 27 groups and got 4 remaining, and then we counted it all up and we knew the answer was 4, so then we brought down the next place value. So now I'm going to bring down the 9. Well, does 23 go into 9? Well, 23 times 1 is 23. So we know it does not, it's too big for 9, so we just put a 0. So we know 23 times 0 is 0, so we're just going to subtract the 0, right? And finally, we're in our ones place, because right now we were in our nines place, so it's basically saying 90, right? So now we have 9 minus 0 is 9. We're going to bring down our 2. So can 23 go into 92? It can, right? Because 23 times 1 is 23. So it can go in for sure once. 23 times 2 is 46, so we know it for sure goes in twice. Can it go more? Yep. 23 times 3 is 69, so we know it could go in 3 times. We'll try for one more. 23 times 4 is 92, so we know that it perfectly goes in 92 4 times. And then if you subtract 92 minus 92, you get 0, so you wouldn't have a remainder. So I have a drawing down here. And so we had 27,692 apples, and I wanted to give them to 23 of my really close friends, right? So I know that each of my friends is going to get 1,204 apples. Now going back to the definition, we kind of reintroduced the definition in the middle of our video. What we did is we distributed some amount of stuff. So we distributed the 27,692 to 23 of my friends. Right? And now, so what we were and then each friend ended up with 1,204. So because we did each of these steps, we were able to distribute some amount equally to this equal amount of stuff to equal amount of my groups, and then we were counting it all up. And this is what we were doing here when we would bring numbers down. We were bringing a number down so we can continue to count it all up until we didn't have to count it all up anymore, right? Until we hit the ones place and we evenly went into 92 4 times, right? So now we're back here is we figured out that when we distributed 27,692 of our 23 stuff, that each group was able to get 1,204 apples, we'll say. So that is how you divide, and how essential it is to start at the highest place value, and why you can continue to bring numbers down, and why we have those zeros there to represent the place value of each number.